Brilliant. Thank you very much. So hello, everyone. Welcome to our summer software special this evening, hosted by us, the fabulous ladies of Cheltenham Hacking Society. Thank you very much for coming along. We're really pleased to see so many of you here. So we'll just go quickly through a plan for tonight. I'll just get rid of that. Plan for tonight. So starting off, I'm going to be talking about an introduction to software development methodologies and a little bit of Python basics to get you warmed up ready for Jenny later. It's going to be not hugely technical to start off with, but it's going to be some of the stuff that you'll hear developers talking about so you can keep up with them and understand what they're talking about. Then followed up by that, we're going to have Sarah, who's going to be talking about version control, so Git. She's also going to be doing an automation demo, and she has prepared what is possibly the most magnificent website I've ever seen. So you've got that to look forward to. No pressure, Sarah.
Oh, so much pressure.
Following that, Jenny has written us a game in Python, and she's going to be talking us through that, how she's built it and showing us what she's built, which is going to be really exciting. We are going to have a quiz and a competition after that, so make sure you're paying attention in the first 3 talks, because we're going to be asking you 3 multiple choice questions, and if you submit the correct answers, you can go into a draw to win a prize. I'll tell you a little bit more about that in a second. And then following that, we've got Sophia, who's going to be doing all the hacks. She's going to be talking about things like stack smashing and a mechanism for vulnerabilities in code. And there are going to be some memes, particularly in my book, because it's a little bit non-technical, but yes, we've got loads of memes for you. So in terms of the prize we've got up for grabs for you this evening, if you get the answers to the quiz right, we have handpicked some coding books for a lucky winner. So if you're new to coding and you'd like some good books to get you started, you could win those. They are supported by our LHS partner, Tech Talent Academy. So thank you very much to them for funding that prize this evening. And also, if you're interested already, or by the end of the evening, you're interested in a career change in software, cyber, or things like data science and AWS, Tech Talent are our LHS partner, and we can really recommend checking them out. And the books you can win, so there's a book on coding in Python, which we'll be doing tonight. There's a book on web development basics, which is really useful. And there's also a book on C basics, so the more lower level stuff. So a really great prize. So make sure you are keeping an eye on the talks. So straight away into mine. So this is going to be a talk on software development methodologies, so you know what developers are talking about. And also towards the end, we're going to talk a little bit about some Python basics, so you're a little bit prepared for what's coming up in Jenny's talk. So we'll dive straight in. So historically, software development followed something called the waterfall methodology. And the reason for that is it's very much based on physical manufacturing. So a good way to think about this methodology is building a car. So for example, you would have the requirements team who would sit together and decide what that car needed to be. So does it need to be fast? Does it need to be safe? Does it need to be big? Does it need to be small? And once they've made all of those decisions, they would pass it on to a design team who would then take those requirements and figure out how to do it. So if it needs to be safe, oh, let's put some airbags in, things like that. And once that design team had decided everything that needed to be done and how it was going to be done, they would pass it on to the implementation team. So that would be the people who build the car, so the people who set the manufacturing lines, the people who actually put the wheels on it, all of those things. And then once that's finished, it would go to a testing team, so verification testing team. They put the crash test dummies in, make sure they're all right. And then the maintenance team, that would be the people in the garages sort of once it's been released. And the benefits of this is physical manufacturing is something that's been going on for a really long time. And these steps are really well defined. And also it's a process that's really familiar to a lot of people. It's very linear. It goes in one direction. We do one step, finish it, document it, and pass it on to the next. And it all follows a nice set sequence. And another feature of this is we have multiple specialist teams working together. So we have a team who are very, very specialized in designing, very specialized in manufacturing. And at each stage, we hand off between those teams. And historically, that's the way the software was built, purely because that was all we knew how to do. Oh, first of the memes. There's a lot of don't go chasing waterfalls memes. Apologies in advance. So in terms of positives, just from looking at that diagram in the previous slide, you could see it's a nice linear pathway. And if everything goes to plan, it's a really predictable, you can plan ahead, you can plan out your roadmap, tell the customer what you're planning to do when, and at each point there's a deliverable to the customer. And customers really like it when they can see that you're on time and you're delivering stuff as expected. Another benefit of waterfall is that it's something that is quite comfortable. So it's something that has been done historically, and you'll find that in many places there are people who have developed quite specialized roles as a result of it. So for example, there might be some people who are specialized in user interface or user experience. There might be people who are really experienced in testing software. Another positive is that customers really like it. And if you want to change it, sometimes there can be some reluctance, even though there's lots of potential benefits that we'll discuss. Some customers might prefer not to. And then the other thing just that we've sort of briefly covered is that when it comes to career paths and planning out your career, historically, those paths have been very linear. So you'll start off as a junior, you'll become more experienced, and eventually you'll become a manager and a specialist. And the more skill you have, the more expertise you have, the more senior you become, and also the more money you earn. So that's historically how those careers have progressed. They've been very specialized and very linear. But one of the reasons we're talking about waterfall is that there are also downsides, and that's been a trigger for change. So every time we pass between teams, even though they're very specialized and very good at what they're doing, every time we pass between people, there is the potential for things like miscommunications, things getting lost in translation, things getting missed. So that's definitely a risk with sticking to the waterfall methodology. The other thing with this is because it's linear, if there's anything that is missed or poorly communicated in the beginning, or any mistakes, and they're not found until later, the later you get in the process, the more expensive they are and the more difficult they are to fix. So that's a big downside of waterfall. If it goes well, it's great, but equally, if there are any mistakes, it can be very expensive and very difficult. The worst case scenario is finding a problem in testing and having to go back to the drawing board, which is relatively rare, but can happen, and that's potentially catastrophic. The other thing is, if you build a product in this way and you don't consider things like security from the very beginning, if you then try and retrofit them at a later date, again, that can be very expensive and very difficult. And the thing that is particular to software compared to things like cars and things like that, you might find in a very long or a very large project, the technologies, operating systems and things that are state of the art when you start that project might even be obsolete when you get to the end of it. So that's a big drawback of it as well. So one of the methodologies that we now have as a counterpoint to that is something called Agile. And when you hear software developers talking about their work and sort of managers talking about their companies and how they work, Agile is a word you'll hear really, really frequently. It's very much a buzzword. And Agile was put together by a group of people who were experts in lots of different programming methodologies. So extreme programming is something that will come up again later, things like feature-driven development. And what they did was they came up with something called the Agile Manifesto. And Agile isn't a singular software development methodology. It's more a set of principles that will guide what methodologies you can use. And there are lots of different methodologies, and we'll come on to that fit under Agile, but they have this manifesto in common. So there's lots and lots of points. And if you want to, you can Google it and have a look. But the main ones are, so individuals and interactions over processes and tools. So basically prioritizing people, building relationships with customers, things like that. The next thing is working software over comprehensive documentation. So in Waterfall, documentation was incredibly important because we were passing products between teams. So documentation was so important, because if anything was missing, you could have those catastrophic events later in the chain. Whereas with Agile, the priority is very much on getting code down, getting it working, getting it delivered to the customer. Another thing that is really important with Agile is customer collaboration. So rather than negotiating lots of contracts and making sure everything's in writing, for example, it's actually having close contact with the customer, working together with them, communicating with them on a regular basis, making sure that we're meeting their requirements at every step. So that's something that's prioritized in Agile. And also the clues in the name, so responding to change. So previously with Waterfall, you had your plan and you followed it very precisely. Whereas with Agile, it's very much about being responsive to change. So if the customer changes their requirements, it's about being able to adapt to that and meet their requirements at every stage, rather than saying, well, that's not what we planned. It's very much about being more modern and flexible. I have no idea whether this slide has landed. I'm hoping you all know the song, and I really wish this was true, but sadly it was not TLC who developed Agile. Much as I would love that, it was actually a load of boys on a ski trip. But anyway, it's still valuable. Oh, and also the Agile Manifesto. There is a man who has made the Agile Manifesto into a rap, and it's definitely something. So have a listen if you get some time. So as I've mentioned, Agile is more a collection of methodologies that have those objectives that meet the Agile Manifesto that we've described. So working software, close collaboration with the customer, and being responsive to change, those things. And you might hear of these different methodologies. The big three ones are Kanban, Scrum, and extreme programming. So just very briefly, Kanban is based on a list of tickets. So each project is broken up into lots of little jobs, and then they are moved between swim lanes. So you've got tickets that need to be done, tickets that are in progress, and tickets that are completed. And there are rules about how many tickets you can have in each column at a given time. But that's one methodology you might meet. Scrum is the next one. So Scrum is one that's quite popular and seems to be very commonly used. So Scrum, you will hear about sprints. So what it is it's breaking up. So your project is broken down into lots of tickets and lots of tasks. And then what you'll do is in each sprint, and a sprint is usually a 2 to 3 week block of time, very roughly, although it can vary between teams. You'll pick which tasks you're going to do in that sprint, do the sprint, do all your tasks with a particular objective. So you might have an objective of getting some code down. You might have an objective for the sprint of security. You might have an objective for the sprint of assurance. So making sure your code meets standards and passes all your tests and things like that. And then at the end of the sprint, you'll have a retrospective. You'll all catch up and you'll reflect on the sprint, look at what you did well, and also what could be done for better for the next one, and then you'll plan your next sprint. So lots of little loops and cycles, and we call that iterative development. The multiple short cycles and sprints is mostly Scrum. And then the final one is extreme programming, which uses techniques like pair programming. So you have two developers working together. So there's two developers working together. And the rationale behind that is you're more likely to spot mistakes as you go. There's also lots of unit testing and also only coding features just in time for when you need them. So extreme programming, when I've heard about it, gives me anxiety, to be honest, but I've never had to do it, so I'm really pleased about that. Also in Agile, you'll hear cross-functional teams used. So with Agile, you tend to have smaller teams of developers. There might be as little as 5 developers in the team. And cross-functional means that rather than having people who are specialized like we did with Waterfall, everyone will work together and learn skills in lots of different areas. So everyone will know a little bit about user interface development. Everyone will know a little bit about databases. Everyone will know a bit about security. Everyone will know about testing. And by working in that way, people bring their interests, but everyone learns about everything. So that's a positive in many ways, but we'll discuss that a little bit more shortly. The other thing with Agile, as we've mentioned, is close collaboration with the customer. So usually as part of an Agile team, you'll have someone called a product owner, who is someone from the customer who is part of the team, essentially. So you've always got someone who you can ask any questions. If you've got any questions, you can always get hold of them easily. And also if their requirements ever change, they're part of the team, so they can collaborate with you very easily. And the other thing with Agile is frequent deliveries to the customer. So the customer feels like they're getting value for money. So every 2 weeks they get something, for example, at the end of each sprint, they'll get something, they'll see what's been done, and they'll see the metrics from the sprint as well. So customers tend to really like that. And again, just mentioning flexibility with changing requirements, keeping you on your toes, and if something comes in from the customer, working to respond to that rather than trying to cling on to the original plan at all costs. So in terms of positives, as I mentioned with those cross-functional teams, developers are encouraged to build a broad skills base, and you get exposed to a range of technologies and disciplines. So particularly when you're early in your career, that's really, really valuable. And you might hear the phrase T-shaped careers described. And what that is basically, if you imagine a letter T, so you've got a broad base of skills in a range of areas, and then there'll be one area where people tend to specialize, and that's your T-shaped career. So if you hear that, that's what that means. It's really positive. Customers tend to really like it because they can see what's happening and they're in frequent communication, which is really important. And then, yeah, this is just a diagram. This is particularly Scrum, but just shows you that we've got these repeated sprints. So we plan our sprint, we design, build, test and review, and then we take our lessons learned through into the next sprint, and we can focus on different things in each sprint and build iteratively, so in lots of little cycles. So another development methodology you might hear about is DevOps or DevSecOps. So DevOps is just the integration of the development of code and the operation, so the running and maintenance of the software out after it's deployed. And DevSecOps is development teams, operations and maintenance, but also the security team involved as well. And key points with DevOps is there is constant delivery of code, constant deployment of code, also constant testing, so deploying it, monitoring it, see what's going on, and using that to make improvements in future. DevOps does have an improved focus on the operation side of things, so code after deployment, whereas with Agile, that tends to focus on the development side of things. DevOps uses a lot of automated tools, so it's more efficient than people doing everything manually. We have lots of tools that do things like test the code builds, test it, check that it passes unit tests. There's loads of things you can automate, so that's a big feature of DevOps. DevOps teams tend to be a little bit bigger than Agile teams and people with slightly more specialized roles. So you'll have feedback from within the team, which again is a really good learning opportunity. Unlike Agile, there is an emphasis on frequent, high quality delivery, so getting stuff out to the customer on a frequent basis. It's worth mentioning DevOps and Agile are different methodologies, but they do have similar objectives in terms of sort of making continuous improvements, continuous deliveries, continuous communication with the customer. So whilst they're not the same thing, their objectives are similar, and also in practice you might find that you're working in a position where actually the methodologies are combined, or for example you're working in an Agile way but using DevOps tools. So there's a little bit of flexibility there. They're not the same, but it can get a little bit blurry sometimes. And then this is just a diagram just so you can see what DevOps looks like. On the left-hand side, we have got the planning, creating, building it all up, and then on the right-hand side, releasing it, configuring it, monitoring it, and then any changes that need to go back are passed back to the development team, and cycle round continuously. And I was a little bit tired when I made this slide, so I got a little bit silly. So just to sum up, in real life, a lot of companies and a lot of teams are moving towards using things like Agile and DevOps. Waterfall isn't dead and gone. There are circumstances where it's valuable potentially. There are circumstances where it's around because we haven't quite made the transition yet. But those are most of the methodologies and the terms you'll come into contact with. So yeah, you might still meet waterfall, but we are moving away from it. So if you're thinking, wow, oh, your question, go for it.
Hannah asks, what is the ops side of DevOps?
What is the ops side of DevOps?
Ops.
Oh, sorry, hang on.
Operations. Operations section.
So it's very much the deployment of the software, so deploying it to get it running in the real world. Also, so monitoring it, so collecting metrics from it, user testing, getting feedback, things like that. Also configuring it. So making sure everything is set up so it's run properly. If there's any bugs that you're finding whilst it's running, any breakdowns, any loss of function, those are all things that are picked up on and fed back to the development team, ready to be repaired for the next cycle. Does that answer your question? Sorry, I can't see the chat.
She said yes.
Oh, brilliant. That's brilliant. If anyone's got any questions, please feel free. I can't see them in the chat, but if you drop them in the chat, someone will shout at the speaker. Or if you want to turn your microphone on and interrupt, you're very welcome to. I think we're a relatively small group this evening, so please feel free to ask any questions at all. There's no such thing as a stupid question, because stupid people don't question anything. That's what Eliza says, and she's very wise. Okay, so yeah, if you're interested in software, how do we get started? And that's something we're very much going to be covering this evening, trying to get some sort of hands-on experience and get you started if you haven't already. So the first question that a lot of people will ask, or certainly one of the first questions that everyone asks, is which language to start with. And there are loads to choose from. And when you talk to people, there are loads of people who have different opinions on what language to start with, based on what they work with, based on what they started with when they were younger. There's lots of opinions out there. And it's just worth plugging now in, if you have access to YouTube, which I think everyone does. In our careers event from January is recorded. There was a talk on that about the different programming languages. So we're talking about Python this evening, but if you'd like a little bit more information about the other languages, that talk is a good one to look at. So the January careers event of LHS. This evening, we're going to be focusing on Python, firstly because as a team, we really like it, but also when you're starting off, it's a really friendly language to learn. But as well as being friendly and easy to learn, it's also really versatile. And you can use it for loads and loads of things, and we'll be talking about that later. It's an object-oriented language, and again, we'll cover that in a little bit more detail shortly. And we're going to be talking about Python 3, and we recommend you use Python 3. So like any software, it's wise to use the newest version. Python 3 has fixed some bugs and problems that we found in Python 2. It's a little bit more simple to get to grips with and understand. There's additional functionality, and Python 3 can be used for things like machine learning, AI, data science, so all the cool new stuff. And also from a security perspective, it's what we should be using. And it's really great, and we're going to be using it this evening because it's great for when you're starting. You can use it for automating tasks to make your life easier. That's what Sarah's going to be talking about. There's a couple of us who work in software, and we use it in our day jobs, like for proper sort of real life software development. And also when it comes to red teaming and stuff, Sophia is going to be talking about that. So yeah, Python's a really great starter language. Just a brief slide on what is object-oriented programming. And I'm really sorry, this is a terrible northern person joke. What is oops made me think of a northern person, so that's Eliza. I'm really sorry to any northern people here. So object-oriented programming is basically, rather than working with chunks of memory and addresses like you do with some of the lower level languages, you're working with coded objects. So an object is just a thing, like a person, or my example here is biscuits. So an object is a thing, and then with those you can also group them into classes which have shared things like type. So you could have a class of objects that are all biscuits, because who doesn't love biscuits? That you can have shared attributes, so you can have things like the name of the biscuit, the flavor of the biscuit, things that describe that biscuit. They can have shared functions, so things that can be performed on all of those objects. So this is very silly, but like you can dunk a biscuit, you can eat a biscuit, you can share a biscuit, and we'll be talking about that a little bit later. And also with your classes, you can control who can interact with those objects. So that's object-oriented programming. Another question that I remember thinking this when I was starting out, like, where do I do the coding? So you can actually just code straight onto the command line. You can write a little program in a text editor, compile it and run it. It's great if you want to do something quickly and you just want to try out a quick few lines of code. But there's a lot of support in other places that isn't present on the command line. So if you like, I've put danger and pain, but if you like having to really work at it, you can do it on the command line, but there are easier places. So idle is a development environment that comes with Python when you download it. The reason for that is Python is actually named after Monty Python, not the snake. It's named after the comedy. So Idle, Eric Idle is one of the creators. So it comes with that little development environment. So that's a good place to start, but it doesn't have a huge amount of features. So the best place that we would recommend is using an IDE, so an integrated development environment. And that is basically software that is designed for you to code in. And it comes with things like, so linters, so it makes your code look nice, it makes it easy to read. And they also have tools like debuggers. So if there's a problem with your code, you can, instead of running it all in one go, you can break it down into little steps. So you can run it step by step. You can look at different objects and what their values are. So definitely using an IDE is very much the way to go, unless you're doing something very, very quickly or you're very experienced. And in terms of IDE, so Jenny, I think, is going to be using PyCharm later. That's her favorite. I use VS Code. There's loads that are available, and it's just a case of finding the one that you like the best. But yeah, definitely look at downloading an IDE, and those are some examples of ones you could try first. So the last little bit of my,
sorry,
go for it, go on.
What is the POC?
Oh, sorry, proof of concept. So if you want to write a quick line of code and just check that that short piece of code does what you're expecting and looks about right, that's something that sometimes you'll break out a terminal and just put it in very quickly if you haven't already got a development environment open. Is that okay? I think that's a fairly straightforward answer to the question.
Nice.
Perfect. So just finishing up, sorry, I've waffled on a little bit. So I'm just going to quickly go through some Python concepts that you're going to be seeing later this evening, just to sort of give you a little bit of an introduction. So Python, one of the reasons we've chosen it is it feels quite close to human language. So there's a lot of words, and the way you lay things out actually is quite readable. But code syntax, so how the code is laid out, what punctuation you use, things like that, that's what we use to tell the computer how to interpret what you've written. So code syntax is basically the coding of the text that you have written to tell the computer how to interpret it. So we're just going to briefly cover comments, strings, imports, functions, and classes very, very briefly. So comments are basically sections of code that are for the developer or for humans, not the computer. So for example, this is a function that does this procedure, or we're doing this because we want to do this. So just little explanations for the developers. So the next person who comes and reads your code can see what you've done and why. And the way we do that is really straightforward. We mark it out with a hashtag if it's a single line comment. So if Python sees a hash, it will disregard anything after that. It won't count it as code. It will say, I'll ignore that, that's for humans. And if you want to put multi-line comments in, you'll do 3 quotes together. They can be single or double quotes, it doesn't matter, but 3 quotes. Put your comment that is for a human person, excuse me, and then close it with 3 quotes. So anything that is marked up like that, the Python interpreter will ignore, and you can put whatever you want in there. Those are for humans, not for the computer. The next thing is strings. So strings is a coding term for a collection of letters and symbols. And most commonly, this is text and words. So for example, if we're asking the user to put an input into a program, so enter their name or something like that, sometimes their telephone number, information like that is usually stored as a string. And also, once we've got that information as a string, as a line of characters, we can then manipulate it. So we can look what's in it, we can split it up, things like that. So the way to mark out a string is just with these quotes. So again, it can be a single or double quote, it doesn't matter. You start with your quote, you put your string, whatever that is, and then you close the quote, and that will be seen as a string in Python. And then imports. So imports are really useful. So one of the great things about Python is it comes with loads of functionality that you don't have to write. So for example, there are modules that do complicated maths for you or handle different data types. So for example, some data forms that you would use in web communications, it'll handle that for you. There's also frameworks where you can build things like web servers. There's loads of stuff. So rather than writing pages and pages of code yourself, you can simply import a module that Python already has. And also you can write your own modules and then import them. So again, rather than writing out lines and lines and lines of code every time you want to use something, you can just import a module and in one line of code and use it on that page. And the way we import stuff is we declare the import at the top of the file where you want to use it. And you'll just simply use the keyword import and excuse me, name the module that you want to import. And there's loads and loads, be it one from Python or one that you've made yourself. The other thing you can do is if it's got a name that you don't like the look of, or you want to change the name to something else, you can use import and the name of the module, and then you can say as R, for example, so shorten it. And what that does is that creates an alias. So rather than writing out the name of the module followed by a method that comes in it, a function that comes in it, which is where you can see random.random. So random is a module that you can use for things like generating random numbers in Python. .random is generating a random integer, and the brackets afterwards show that that's a function, and we'll talk about those in a second. Rather than writing out the full module name, you can actually alias it to an R, so it just saves you typing it, just makes your code look a little bit neater. And then the final thing is it might well be you don't need to import the whole module, you just need one function from it or one part of it. So if that's the case, rather than going import and the whole module, like how we have above, you can say from the name of the module, import, and just the part you want. So that's a more efficient way of doing things. Rather than importing everything, you can just import one thing. Oh, sorry, more means. And then functions. So the best way to describe a function is it's like a little program written within a program. And what it is, you can, in a function, you can write lots and lots of instructions. So for example, say it's a set of instructions that you're going to need to carry out more than once. You can define that in a function. So you can write out once the name of the function, what you want it to do, and then each time you want to execute that sequence of instructions, you just call the function. So you just write, rather than writing however many lines of code, you literally just write one line of code. And Python comes with its own list of functions. So basic stuff like, I don't know, breaking up strings or adding things together, basic stuff like that Python has, or you can actually write your own. And in orange here, I've just got how to define a function. So def is the keyword, and then biscuit warning is the name of the function I'm defining. And what we're going to say is whenever we call this function biscuit warning, we're going to print the words paws off my biscuits. So now we've defined that function. All we need to do every time we want the machine to say print paws off my biscuits, all we need to do, rather than writing that out each time, we just need to call biscuit warning. So writing the function name with the brackets after it, and it will print out paws off my biscuits. So functions are really useful for keeping your code nice and tidy and repeating lots and lots of instructions in one simple line of code. So they're very, very handy. And then the final thing you're going to be seeing later in Jenny's game is classes. So we mentioned it's a way to group objects together in a group of objects that have common things, lots that have things in common. So the same attributes, so that they all have names, they all have ages. So with people, every person who's in the class of person, so everyone who's in it is a person, they all have a name, they all have an age, for example. So it's just a way of grouping objects. And then another reminder with the terms is the class is the type of thing that something is, or the group, and an instance is an individual member of that class. And the way to define a class is with the keyword class, person is the name of the class, and then also we'll use this magical constructor. So we define and then use the magical init. Self is the instance of the class, and then everything in that class will have a name and will have an age. And then we define self.name is name, self.age is age. And Jenny's going to be covering this in a little bit more detail later. But this will basically create a group of objects that are all people and each has a name and an age. So that was a little bit of a whistle-stop tour. Does anyone have any questions before we continue? I'm going to take that stunned silence as a no. So I'm now going to hand over to Sarah, who's going to be talking to you about Git version control and also her amazing automation demo. So I'm just going to stop sharing the screen and hand you over to Sarah.
Thank you. I will just share my screen really quickly. I'm still on your slide. Nah. But all right. So first things first, does anyone know what Git is? I feel like this is probably a bad point. You can unmute and be like, yes, I know what Git is, or, you know, I'll just take the silence as a potential yes and no. But Git basically is a version control system. It's a remote cloud-based repository for a bunch of different repositories of code, really. There are so many different things that you can use Git for. So Git can be used for word lists, for example. There are so many people that just host extremely large files full of word lists that you can use for hacking, or you can host your own fun little script on there, which I've done, which I'll show you later on. And Jenny's got her fun game hosted on Git. You can really do what you want with Git, but it's just a place to store your code, really. So GitHub sits remotely, and you can log into that through a nice little GUI and an interface. And then you can also interact with GitHub and your code locally on your computer, which I will demonstrate for you later on and talk through some of the commands a little bit more in depth. But really, Git is a great place, and you can work collaboratively on other people's code. And you can also make pull and merge requests, which I'll also talk to you a bit about as well. So why use it? Which I'm sure I've already kind of touched on, but you can use it to track your changes. It's quite a good place to store your code, sort of like a backup as well. So I use my dissertation for my, I use GitHub for my dissertation, so I can store that there, and I'll know that if something breaks or there's a file that I've changed and it's, you know, messed up somewhere, I can go back and look at like a historical log of all my changes, and it's just there for you. A lot of companies actually started using Git as well to store their code in this new technological world. And then you can also, when you're collaborating, work off different branches as well. So I've got a fun little diagram. Now, when it comes to programming, I'm still a complete and utter noob. So, like, to be quite honest with you, for the longest time, even though I was using Git, I was pushing all my changes straight to main, which might not make much sense to you right now. But let's say we have, I don't know if you can see my mouse. Can you see my mouse? Okay, so let's say repo 1 is my repo. You can make branches, so you can develop different features, but there's also like your main repository. So repo 1, there's the main repository. I was at the level of writing code and pushing it straight into repo 1, which means that if anything broke, I might not have been able to actually change that. But you can create branches, which you can see further down here. I haven't got the best diagram because I should have included multiple more diagrams now. I'm shooting myself in the foot. But yeah, so I have my main repository here that I was pushing to, and then you've got like other levels where you start using a branch and then pushing a branch directly into main. And you've got another level where you've got a branch that tests your code, and then you can merge into main. Like there are so many different ways to actually use branches. That's brilliant. Anyway, so version control. Let's say you have this repo. I've got my repo, and someone has forked that repo. I don't know why they would want to. You have now got a clone of that repository there. You can make changes, and you can also try and make changes in a branch and push these changes to the main repository. And you can go through and check off the changes. I'll look at this in more detail anyway, but you can see the different versions of the code, or that maintainer can see the different versions of the code there as well. So there are so many different things that you can actually do with Git. So personally, when I've been using it, I've just used it for a single project. And I have it running in a Kali VM, which I'll show you later. When you want to start with Git, assuming that you haven't used it before, all you have to do is just do sudo apt install Git. I don't know why I put a capital letter there, shouldn't be there, but just sudo apt install Git, all in your command line, and that will install Git for you. Configure your global variables. These are used when you're pushing your code. You can see who's made the changes. So for me, it will just be my email and my username. And you interact with your remote repo in GitHub I've personally set up SSH keys. So I've got my public key stored in GitHub. So whenever I push my changes, it automatically just does it. I don't have to put in a password multiple times and things like that. And then, yeah, I just realized this is meant to be animated, but a fun little song list of Git there, which you should definitely go and check out, that I think we mentioned earlier. And I was listening to it. It's a great playlist just to listen to music whilst you're programming, if you're starting to program just like I was, from just getting the zone to that. So yeah, a bit more about it. Let's say you have gone into GitHub, you've created a repository, and you now have like some code or a file of some kind. You can go ahead and clone that repository so you have it on your local host, modify the code, add a file, do what you want to it. And then when it comes to it, you add all those different files and the changes to a staging area before you then actually commit these changes. So if you have quite a large checklist of things to do in your code, let's say I'm going to have to use Nat's example of, let's say you have a Biscuit class and you're going to add all these different functions. You might want to add these functions and like different files that you're using to interrupt your code in a staging area, and just check it off like a checklist before you actually commit all the changes that you've made. and then you push all your changes to the remote repository. And I'll go a bit more in detail about the commands that you'll use for that as well. And then, yeah, Git branches, which I did just briefly mention. You can use this to create a new branch, switch a branch, and like you use this basically as sort of, let's say you have features on your code, you can use it just to manage it better. Let's say you wanted to make changes to biscuit.py. I don't know why I'm using your examples now, Nat, but I am using your examples. Let's say you have biscuit.py as a feature, then you have cupoftea.py. You can have two different branches, cupoftea.py and biscuit.py, and you can merge those changes when you're done at a time that's convenient for you, which I'll show you some commands and how it's working. Once you merge them to main or merge them to testing, test them, add it, commit it, push it, make sure it's all working, add it to main, then add it, commit it, and push it. It's kind of very repetitive when you're going through it like this. Like I said here, it's the exact same. You do git add once you've made the changes and commit it all, which I can show you later. This just sums it up really, doesn't it? Git commit, git push, and then just get out of there. When you finish your coding, it's frustrating because mainly coding only goes well 10% of the time. That's what I find when I was scripting. You'll see that soon enough. And then you want to do a Git branch first. So I thought, whilst I'm talking about Git branches, best add in some commands here. I'll actually show you how they're working in a minute, which might make a little bit more sense than me just speaking at you, because I find slides are never the way to go for me. I always need to just show people how it's working. So that's why we need to pray for the demo gods and see if it's going to work. But that is the main thing about main commands, and you can just access them later if you can see the slides whenever the video goes up. But Git, yeah, it's also used, like I said earlier, in companies. You use it to collaborate on. So one person might be working on one branch, so biscuit.py, and another person might be working on another branch, so cupoftea.py, for example. Or someone might be working on their forked repository and then wanting to push changes to that original repo. So really, it's up to the owner and it's up to different people how you want to collaborate, which does mean you can just collaborate on code, like on anyone's code, pretty much, given they allow your request and you can commit it. I'll show you what I mean in a minute. This is probably going to make no sense when I'm talking about merge and pull requests, just in a side. And also, like I was saying earlier, you've got a historical log that Git saves, and you can access that through the command line just by entering git log. And I'll show you that in a little photo because it's just a bit easier. And you can see there my username and my email. Just DDoSing myself here in there, and that's the log of some of the changes that I was making to my repository. You can see that in your own. And then you can also access this through GitHub as well, so through the GUI. But honestly, enough of me talking in slides. I'll just show you what I mean based on the script that I wrote and then how that script is working in terms of automating. So if I just end the slideshow here, lovely jubbly. I started, this is my environment that I mentioned briefly earlier. I started developing in PyCharm because Jenny suggested it, and I was like, yeah, let me check this out, and it's actually really good. When I wanted to clone my repository, have a repository all set up, it's lovely. I just realized everything is back to front. Can I hide this bar? Does anyone know how to hide this bar? Okay, right, well, it's fine, I'll just click it in a little screen. So I have my Git repo here. If no one has seen a Git repo, it's called LCHS Chelt, just because I thought I'd use it whilst I was developing, which might make a bit more sense now than my slide. I cloned this repository. It was far more empty when I started working on it, but I cloned the repository in my command line. And because I've already set up my SSH keys, it allowed me to do this. So here's my repository. I can list all the files for you. And when you want to get there, when you're cloning, you just do git clone, and then you can quite easily clone by doing this. And I clone with SSH right there. It's not, if you didn't know how to do that before. And then you can work on it. So make changes, add your files, all of that. And like I said before, when I started coding originally, I just pushed everything to main. But quite frankly, creating branches just makes your life so much easier. So for example, if you're working on something huge, which I need to teach myself how to properly code because I am going to start working on a much bigger project, then you can use branches just to push features as and when they're done. And you can change like the main. So if you want to create a branch, for example, I'm here. If I do git status, find out what branch I'm on main. If I want to create a new branch, because I want to add a new list, I can do git branch list, and then I can do git branch -a to see if my branch is there. And as I can see here, I've got list. I can just switch into that, git switch. Yes. Now I've got all the files from main in this branch because that's where I've just created a new branch from there. And I can add in another file if I want. So I could do touch test file.txt because why not on this lovely little demo? And then I can switch back into main. I know now because this is an empty file. This isn't going to actually hurt my code in any way. And I can do git merge, and then oh damn, this is why you have to pray to the demo goals. I just realized I did not commit any of my changes. So first things first, you want to commit that new change to your list. So git add the file changing because that's one you've just added, and you can just go ahead. So if I wanted to add another file now, actually, which will make more sense. Directory.txt, let's say. I can do git add again, all the files in the directory, that's that little dot there. And then I can do git commit -m for message, enter, and that's committed these files. Git push, and then push them to that branch. And for some reason, it always asks you to run this. I did Google this on Stack Overflow because I'd never seen this before. But I don't remember it's something to do with the versionings of Git and the reasons why it's pushing, but it's basically just specifying the branch that you're pushing to. So I push that to that branch, and we can see this in the GUI in my new list branch that these have been pushed. There we go. So there's list, and there are the new files I've created in the list. Now I can merge those files into the main. So git switch main, and then I can do git merge, and then list because that's the new branch that we have created, and we want to then merge that. And you can see here we have all the files. .txt there. We have all the files that we've just created, but they won't show up here because we haven't yet pushed them. So we've got to git add file to the staging environment, commit --message, and then git push, see the changes, and it should show you these changes. There we go. So there's dir.txt in the main branch, and you can see that through the GUI as well. And we can see in the history in the GUI again that we've committed and all the different commits all the days ago, etc., etc. So that is my repository and how I've been using it. And I'm trying to teach myself to use branches more often because they can be so useful. And then also you've got the history and you can revert the code back if you need to, if you make any wrong changes to it. And then, yeah, so let's actually talk about the proper code. This is, can you see this all right? Please let me know if you can't. I don't know how you can zoom in.
I want to zoom in a little bit, Sarah.
I see.
You can control and scroll.
Oh, nice.
If you've got a mouse.
Doesn't seem to like that. Maybe I will. No. Okay.
That's a search.
Oh, demos. This is okay, right. Well, the code is on my repository and that is public, so you can just see that. If you can't see this very well here, I'm really sorry I can't zoom in right now. I've never actually had to do that in a demo before. But I have my imports, like Nat was talking about earlier. And from that, I've imported argparse. This is just one sort of like method of using arguments in your code. So if I ran my code as it was without any arguments, and my code is a Derb 2.0. If anyone's heard of Derbuster, it's a great tool, and I fully suggest you use it over Derb 2.0. Derb 2.0 is just my way of creating a script to brute force directories. So Derb is a much better script that brute forces directories to a website, hence why I've created a website. Before I just completely forget to give you any background on this. So my script is just a very, very brief script to automate directory busting or brute forcing. So if I run this script here without my -f argument, for example, it shouts at me and it goes, "You have not entered in a file." So I need to then run my script with my -f argument and my URL specified here because I want to brute force directories. I've got here like a little function that goes through and checks the URL and checks the status of the URL as I put in that argument, and there's room for human error. Then I've got here another function that gets the directory, make sure it's a text file, and another function here that then adds the directory from the file to the URL. So you could specify any kind of list here in this script. You could just create your own little dir list. That's what I've done here with a bunch of very obvious directories. And then you go through and it runs all the functions in main. Now, Jenny will tell you much and teach you much better coding practices than my little script, because I'm not the best at it. So this is what I've put together, but that's the beauty of GitHub and creating code, is it is what you make of it. It's just a creative, fun process, and you can just learn as you go. So this is my early days programming, and hopefully in 10 years time, I've become much better. So I'll run my script, and it is busting all these directories here that I've got listed. So I picked up that index.html exists for this website and LCHS.html exists for this website. If I originally just go to the website, I wouldn't know that these pages existed, because all it is just, this is not the greatest website in the world. Hello world, this is the greatest website. This is just a tribute. It doesn't tell me that there's another directory. You wouldn't know this unless you ran that or did some kind of crawling. You can see the view of the page, it's just basic HTML. But we've also found these two. So index.html is a basic like index. It's the landing page for the code. Basically, it's what I've created and what I've saved on my web server as the home page anyway. But you don't need to specify that when you're going to it. And then LCHS.html is a lovely little hidden directory, and you can try and run this script yourselves to try and find it, because I'm not going to take down the web server for quite some time. I'm quite frankly going to forget about it. So you can try and create your own script to brute force a directory, or just run derb against it. It's completely up to you. But that is the beauty of scripting in general, programming in Python. It takes you, I'm going to say 2 seconds. For me, it did not take 2 seconds. It took quite a long time. But, you know, eventually when you get used to it, it can really help you with some large tasks that you don't want to do. Like, I don't want to go through and sit through and enter words. But yeah, that is pretty much it from me. And then I will hand you over to Jenny. I'll just get up your slide. But I realize I have to go because I'm doing a night shift tonight. Lovely juggling, and stop sharing. There you go. This is on to Jenny. I hope I didn't fly through that too quickly or ramble on for too long. But do feel free to ask any questions. I realize I've not said that in the chat, or just ping me, because I will get back to you if it hasn't made any sense. Yeah, that is it. Sorry, Jenny.
Are we going to do a quick break first?
Yeah. So
we're going to give everyone.
Oh no, Jenny, you go.
5 minutes, 5-10 minutes. Go, have a wee, get a drink, come back, and then we'll crack on with the demo, basically. Cool. Hope everyone is back from the break. I'm Jenny. My job is a software engineer, so I write code for a living. This is what I do and what I actually enjoy. We're going to be looking at some Python today. And now it's distracting me in the chat, and I'm going to need to minimize that. Go away now.
I was saying your introduction was amazing. I forgot to do that.
Well, I'm a person. I do some work every now and then. This is Python. I use PyCharm to develop Python. That's just what I've always done. I think software people can slightly be creatures of habit and things like this. We have our own IDEs that we like to use for specific things. Matt likes VS Code. I use VS Code for JavaScript because for some reason that's where my mental boundary is. So this is PyCharm. I like PyCharm for Python. It works great. And I'm just going to be doing a really quick walkthrough. I've written a super small, like, choose your own adventure style game. And I'm just going to go, we've got 4 classes. It's quite small, and we're just going to go through those 4 classes really quickly. I'll give you a super, like, small overview, and you'll see a few things that Nat mentioned at the beginning. I'll do a little bit more into actually some of the structures that are within Python. And then we're going to give it a go. I will unminimize the chat. It's choose your own adventure. So we will choose our own adventure, and I will line by line go through, and I'll input stuff, and then we can see how it goes and how it progresses. And fingers crossed, I've written this and so it doesn't crash. There's always a chance that this will crash. But so from the top, this is Python. And this is my class main.py. All Python files have the file extension .py to show that they are Python. And just for convention and habit, really, I always put a nice big comment at the top of all of my files, generally saying what project it is, what the year was it was written. Sometimes I'll write my name in it, because then it shows, if it's on a larger code base, who works on which class and who's sort of responsible for it. You can blame somebody later on. And then, as Nat mentioned earlier, here are the imports. Now, these are the 3 other classes that I have written. So these are all the internal imports. In one of the other classes later on, I'll show you some Python importing some external stuff that I did not write. But these are the imports of all the classes that I have written for this. And then we have our class. Got the little word class to show. Python is really great. I think it's quite obvious what things are and what they do. It's quite readable because it's quite a high level language, and so it's perfect for getting started, really. And then each class, I comment to say what this class does. See, in more bigger code bases, it'll be like a more in-depth version about what's in here. But this is what our game is, and this is where our game starts. And then this is the first function that we have within our class. And this is something that's called a constructor, and this is the thing that makes the class. And the underscore init here, this is a magic method, and that is what the constructor of the class is. This is a thing behind the scenes in Python that it just knows when it sees an underscore init, that's what constructs the class. And it self represents the self there, that represents the class, game, and then it will reference back within itself and all the functions within this class. If there are any questions as I go along, seriously, just interrupt me, like unmute yourself, stick it in the chat. Nat and Sophia can then shout at me and ask questions. But the whole aim of this is to be super interactive. If you're totally new, no stupid questions. I've done this for several years now. I might just go way above what, a basic level. So just no stupid questions, just interrupt me. And so we're going to just have a little look about what's in the rest of our game class and then move on to the other ones. So we have a few functions in here, which we will walk through line by line as we go along later. But again, each one has its own comments to say roughly what this little chunk of code does, so that as somebody else coming along, you roughly know what's going on. You don't have to be like, oh, setup, what does that do? Often, the function name is fairly self-explanatory, but you never know, there might be some intricacies in there about what is required. So we've got a setup function, start function. We'll go through these line by line in a second. But as you can see, there's code in here. These big red dots, these are my breakpoints. So when we debug later, that's where the code is definitely going to stop. And so I can make sure that I can show you it in lots of detail. And then here we have a little apps thing. This is referred to as a decorator. And this is, again, some magic Python-y shit that happens behind the scenes. So a static method is one that doesn't take in self. So all of these other ones, because they're members of the class, they take in self, which is the game, the instance itself. Whereas this static one doesn't. It doesn't have anything to do with game and the objects that are on game. This is other stuff. Just seen that smiling a lot. It's really I have no idea what's going on. So right at the bottom here this is fairly important. So this is where the code all kicks off. This is where the game begins. And so we can see here that it's if name equals main. And in Python, if you see a double underscore, it means that there's something a little bit weird, a little bit special going on. And this is because when we run this class, this is what it goes to. This is what starts. And I could have just written these down, but then if I'd have started the class, it would have gone automatically. If I'd have imported it, it would have started it without me having to say start this class. So you want to really make sure that it starts, the code runs when you tell it to run, and not just moderately, not randomly, but when you're not expecting it to, so that you can import other classes. So that's a general overview of this main.py. That's where we're going to start. And I'll just quickly show you the other ones, and then we'll get going into actually running some code. So this is another class. This is my person class. And this was something that if we go back to the main, you can see here it's imported at the top. So we've imported person from person. So this is person. Fairly self-explanatory. It is a class to represent a person. And as before, we have our constructor, and that constructs our person. And this one takes in some stuff. And it's not essential in Python, but I really like to use something that's called type hinting. And that's what you can see here where it says name colon str. The str is for string. You could also have other different types of objects. You have, arrays, dictionaries, whatever. But it indicates what I'm expecting. So I'm expecting the name to be a string, and I'm expecting your favorite animal to also be a string. And then in here, I also have some comments, and it says what parameters that we're taking in, what about them. So if there's anything more to them, I can deal with it in here. And then these are the attributes of the class, the name and the favorite animal, and those are set on the class itself. So we've taken it in here, and then we assigned it as an attribute to the class on line 17 in the self.name equals name. I didn't have to call this one name and that one name. They could have been slightly different. It's just that that's what I've called them. They happen to be the same. Another thing to note is that I have set these to have default variables. So if I constructed this class, but I didn't bother giving the person a name or a favorite animal, it would just set both of them to be this string that is empty. And that means that I don't necessarily need to have those two variables in when I construct the class for the first time. So that's just really briefly what our person looks like, the bits that are the attributes that are on the person. And now we are going to go to the beach. And so this is a beach. This is actually going to be our main class that we're going to have a lovely time at the beach later. We've got some activities planned, and we're just going to have a nice time. Hopefully it doesn't crash, and if we don't, find the shark. So for the first thing to note here at the top of the beach class is we have some slightly different imports. So rand range here, this is not something that I've written. This is one of these useful Python maths bits, and this gets some random integers between two numbers because I'm going to set this up, and this is actually going to tell us when the sun is shining and how long the tide is out for, which is important information when you're going to the beach. And this from typing import list, this is to do with the type hinting that I mentioned earlier. So we have a list in here which is like a shopping list. You write it down, it's just strings or integers or something in a list, and just that's it. There's nothing else to it. There's nothing else fancy about that. But I want to make sure that one of the things that is taken in is very clearly a list and not anything else. So that if you put a string in instead, it will go, you shouldn't really be doing that, and slightly tell you off because you're being naughty. And then if we just have a quick look down the rest of the beach class, this is quite a long class because it is where a lot of our code is. So again, we have our constructor with our init and the magic method there, and it's taking in the player. And we'll see that the player is something that obviously in the game, you are a player, and that's something that's taken in between each class, and we can still reuse. It's the same player, it's still you, it's still the person that we create, but we're just going to move it around, and it's going to be like a really little useful building block that we can use later on. And as before, we've got our functions, and without too much of a sneak peek, we're going to do some cool stuff. And then finally, we have one additional class, which is forest. And if anybody is feeling inspired and wants to get involved, this is sort of like a boilerplate. I've set it up. There's a start here, but it doesn't go any further. So this is for you to fill in, exercise for the reader at home. This repo is all up on GitHub, so you can do your own clone, you can fork it, you can do whatever. You can take your own little version and play around. And if you want us to send it to us later, we would love to see it, and that would be amazing. So I think basically let's get going. I'm going to try and work out how to get the chat back, and then I can see what is going on. So the first thing we're going to do is we are going to debug the code, which is where instead of just running it and you just let it run and you're not entirely sure what's going on, debugging means that you can go through line by line. You can really slow it down. You can see what your objects are at various points. You're not just blindly guessing what your code is doing behind the scenes. You can line by line step it through, slow it down, and then just see what's going on. So we're hopefully going to debug, which is this little bug up here. Cool. As I said before, and just a little reminder, these big red blobs, there are breakpoints. That's the points where I've said to the code in particular, stop at this point. I really want to look into this point further. If I don't have breakpoints in and I just let it run, even in debug mode, it wouldn't stop. I'd have to tell it to stop so that I can look into it in more detail. But here we go. So hopefully you can read. So down here, this is our console. It's a choose your own adventure. So really, really old school. We're going to be putting text in on the console and I'm going to have to type it out. So straight off, this first line here, you can see that we've gone into the if name equals main, and that's because I've started in the main.py class. And the first thing we're going to do is we need to construct our game object, because that's where all of our lovely bits are. So I'm going to use this step over down here. You can see my mouse, it's this little one here, and that means we're going to step over it and go in. I put loads of breakpoints in already, so hopefully it shouldn't run away with ourselves. Awesome. So this is the constructor of our game. So that's what we looked at earlier. So this starts it all up. So that is the fact that it was just a game and then just the brackets. So that's going to set it up. And we can see the first thing we're going to do is we're going to also construct a person. And that's going to be the person, us, that we're going to use later on throughout the game. So I'm just going to keep stepping through that. And we can see that it's now going to be, if I hover over this, it's really tiny, I'm afraid, but you can might be able to see that that has an empty string in it. It's just got the quotes and that's it. So it's come in, we haven't given it stuff. I go back a line, you can see the person didn't have a name, it didn't have a favorite animal. So we're just using the empty strings and we're just going to assign that. So we just step through a little bit and then we have set up our game. Well, we've constructed it. We're now going to set it up, which is something that I have defined as a function here. So we're going to just go into the setup. And so we can see that the first thing that's going to happen here is the username is equal to input, what is your name? And if you look down on the console down here, it is asking us what our name is. So input is a thing that goes onto the console, and then we can input our details, and then it picks it up with the username equals, it assigns it to be username. So
I have a question.
Yes.
So in that console, whenever you press that next button,
yeah,
is it going from the one breakpoint to the next? Is it like just running the code between the breakpoints?
Because I'm stepping over, I think I will have to work this out, because there's step over and step into and other things. It should be going line by line and not breakpoints. If there is, because I'm in an input right now, it won't give me the options, but if I just click and continue to play, it will go straight over to the next breakpoint. So there is the option to go line by line, super granular detail, or just fast forward to the next breakpoint. Step into goes, if there's a function, to go into that in more detail to really analyze that.
Thank you.
Awesome. So down the bottom here in the console, so the console right now is inbuilt into Python, into PyCharm, but we could also obviously do it on a command line and run the Python script from there. But because we're debugging, it's all within our magical IDE. So I'm just going to enter my name into here. And we can see that username is now Jenny. And because it's in debug, we can really clearly see that that's what it's assigned to be. And then if I step over it again, it now asks us what our favorite animal is. And so would anybody like to write an animal into the chat? And I will attempt to write it into here. Dee's in there first. We've got a panda. So we can see that we're now going to reassign self.player. So that's the player that we created earlier, and we're going to actually create a new person. I could have reassigned those, but that's just the way that I've done it in here. And I'm now going to take the username, Jenny, and the favorite animal, which is now a panda. and I'm going to go back into this person object and create that. But now that the player, which is on the game class, now has those attributes. And then there's a little print statement, and then we're going to get going onto our game. So then we've just done game.setup, and the next thing we're going to go into is game.start. Just going to start the game. So the first thing we're going to meet here is it's going to ask us, would we like to go to the beach or the forest? And as you saw, spoiler alert, that the forest doesn't go anywhere. But this is the first thing we're going to meet is an if-else statement, which is also known as a Boolean statement. So it very much depends about what is true. So if the adventure, the double equals is an assign, no, it's not an assign, it's a comparison, whereas a single equals is an assign. So this is saying that if the adventure that we're going to input as a string is the same as beach, then go into this bit. If the adventure, we've given it forest, it goes into this bit. The elif is an else if, and it just gives us little statements within, and then else, that's anything else that didn't fall into the statements above, it'll go into here. So we're going to go to the beach because that's actually where the fun is right now. So I'm just going to put beach in, and we can see that adventure is now being assigned to beach. And because adventure is equal to beach, we're going to construct the beach class. That's the beach with a capital B, and then with the brackets around there. That's going to construct our beach with the player that we've already created. Then once it's constructed that, we're going to start and go into the beach. So I'm just going to click on through. So as you can see up here, it's a bit small, I'm afraid. We are now at the beach. And we are in the constructor for the beach. So that's the first bit. That was the beach with a capital B, and then with the brackets around it with our player. So we can see here that this, oh, it's really small. When I'm developing, this is fine, but obviously to display on a screen, it's really tiny. So you can see potentially that that's got a person object. That is the person object that we previously created. It's not a new one. This is the exact same little blob that we carried around from earlier, which we're just going to move along. So we can see that we've set that the player is equal to the player that we had before. And then we've got some other attributes that weren't ones that we passed in, but are relevant to the class that we're going to use later on. So we're going to set that the sun is currently shining, the tide is currently out. So I'm just going to step over those two lines, and then we've assigned that. And then there's two other bits we're going to have. We need to set when sunset is, and we're going to need to set when the tide comes in. And this rand range is what was in the imports at the top. We're going to use that. And I've just said, so rand range gets any integer between a certain value and another value. And that's just what I'm going to be using as sort of our when the game is going to come to a close, which we might reach. I might think that we've gone too long. So we can see that if I go on, it should set self.sunset, it's tiny, I'm afraid, is now 5, which is an integer between 4 and 10. And then also we can set the tide is now 8. So effectively in 5 hours, the sun is going to set, and in 8 hours, the tide is going to come in. And we are now setting the time to be 0. Developers love to have things that index from 0. Stuff indexes from 0. We like zeros. It's all good. So now we have set up, that is constructed our beach. So we're going to go back. So that's done this first bit here. We have our beach, and now we're going to start playing at the beach. So as we see, we've gone back into start in our beach class, and this itself is referring to this beach object that we have just constructed and created. So there's a few print statements to start because we're friendly. So welcome to the beach. The sun is shining, the tide is out. However, if this changes, we'll need to leave the beach. And we now have what is called a while loop because it has a while. So it combines these two statements here, which is the self.sun shining, which is up here, which we have set to be currently true, and the tide is out, which is true. And an and statement combines true and true, so that is true. So what and a while loop is when this full statement here is true, it continues and it'll just keep chugging around, happy times. But if that statement there changes to be false, it will exit from that loop, and then that's where it, you know, comes out of that. So we are now going to play at the beach. So what would we like to do? This here is the selection of activities, and this is a dictionary. And a dictionary links a key, which we currently have as A, B, and C, to a value, and often so a dictionary combines key value pairs. I mean, sort of like a dictionary where you have your words and then you have your definition. We have our key and then we have our value afterwards. And so we're just going to, this is now as I realize there's a lot going on right now. There's lots of little bits that all build up to make code work, and it's all got slightly different uses and it all sort of stacks on top of each other. So this for loop, so this will go through all of the keys, that's A, B, and C here. That will go through all the keys in the activities and prints out our activity key. So we're going to print out the activity key here, and then activities with these squarey brackets, there's so many brackets, will then print out. So the squarey brackets will then link back our key value pair. So we'll put our key in, it'll look back in our dictionary and go, oh, look, this is the value that's assigned to that key. So we're just going to quickly pop through all the keys, and you can see on the command line down here, it will go A, B, and C, and then it will exit. And then it now wants us to choose A, B, or C. So do we want to build sandcastles, swim, or go sunbathing? So we have a vote for B. So we're going to put B in. So I've put a little bit of handling in here because we could have put something absolutely rubbish in here. So the chosen activity key is B, which is in activities.keys. But if it wasn't, we would have gone into this print statement that said, oh, I don't know that one. And then it would restart play, which is the function that we're currently in. And then it would go back round and it would ask us again. But we put in one that it does recognize. So it gets our chosen activity. So activities is the dictionary, chosen activity key is B, and it will look up in the dictionary that was defined up here, and it will say, B, you know, from the key, the value for that is going swimming. So then we keep on and we're going to go swimming. So this is another Boolean statement or an if-else statement. And we can see that our chosen activity, it's quite small, I'm afraid, is swim. So instead of, it's not going to go into that first one, it's going to go into this else if chosen activity equals swim. And we're going to go swimming. So you can see in the command line, we're going to get in the C, and then it's going to ask us what stroke. Sorry, where is the if? Let's go back up. This F here, Dee Dee. Yes, so this is because I have inserted this string straight in. So that's, I think it's a format. So it puts it straight in instead of having to do like some ugly stuff. It's a really neat way of combining bits of that we have assigned into the print statement that we are with the string that we've given out. And so it all sort of smudges it together in a nice way. So it's asking us which stroke we should swim. So that's back down here. So anybody, I mean, you can see where the shark is. It's really annoying, but we have got to the shark. So if I was to put in, we were swimming in butterfly, we can see here that it would go, I'm not good. Let's get the shark, shall we? It's more interesting if we actually get the shark. So we're going to go and do some butterfly, which is great. But unfortunately, there is now a shark. And that means that we need to get out of the water now. Like, sharks are bad. We're not friends with sharks. We like pandas. Pandas are good. Sharks, clearly not. And then we have a return statement. So that means we are going to get out of this function. We do not want to be here. Like, get out right now. If we hadn't have got that, we would have just, you know, potted down to the end of the function. That would have been fine. but the return statement means we are getting out of this function now, don't continue. So we are quickly getting out the water, and we have exited self.swim so that we have stopped swimming. And then for each go in play, we have also set increment time, which is how we know that time is continuing on. So I've just said that after each go that we've either gone swimming, we've either built sandcastles, or we've gone sunbathing, then time progresses on in a unit. Let's say it's an hour. And so we are going to increment time by 1. So this plus equals just means whatever it is right now, add 1 to it, reassign it, lovely stuff, all combined in 1. And it's now we've got some little greater than symbols in here, so maths. And that'll say that, you know, if the time is greater than the sunset, the sun has stopped shining, we assign that to be false. Or if that the tide, you know, has now gone in, we are now, well, the tide is now not out anymore, so that's false. We're just gonna, that's fine. And I think I'm probably going to leave it there, because I think that's given a really lovely overview, and also means that if you want to have a go yourself, there's still more to explore. You could still build sandcastles, and you can still go sunbathing, and there's other little codey bits and bobs in there. But I think that bit that we've done just right now gives a little bit of an overview into different building blocks about how Python in particular works together, and how what you can create from it. So if there's any questions, yes, that. So for reference, and that's the thing that I'm good at maths, I've got a maths degree. So that's a really key thing. I didn't come from a computer science background. That's not where I've started. I did maths to begin with, and I decided during my degree, I quite like writing code. And so I decided I'd do that as a job instead. So if there's no questions, I'm going to hand over to Sophia and stop sharing.
So just while Sophia's getting ready, we're just going to quickly do our competition. So I'm just going to share the slide. We'll just do it really quickly. Share. Fab. So just a reminder that we've got a prize, and it is a hand-picked selection of coding books that we've put together for you, including Python, web development, and C, so covering lots of different languages. And all you need to do to enter is to answer these 3 questions, and they're on your screen just now. And what you need to do is decide on your answers, and then write them together in a list. So A, B, C, separated by commas, send them to me by DM. And then what we'll do is we'll make a list out of everyone who's got the correct answers. We'll put them into a list, we'll generate a random number, and the winner will get those books. So the questions are, what is the term for a mini program within a program that you can call? That was from my first talk. And your options are A, function, B, class, or C, comment. The second question is, what is the command to create a new Git branch? And that's from Sarah's talk. So is it Git branch and then the name of the new branch? Is it Git branch tag A, or is it Git checkout and the name of the branch? And then the final one is, what is a magic method for a constructor for constructing a class in Python? So is it underscore init? Is it init with an exclamation mark, or is it underscore main? So if you just pop those, pop your answers, so A, B, C, or whatever they are, pop it in a DM to me. I'll make a list. I might ask Jenny really nice if she can generate a random number for me, and we'll do that during Sophia's talk. So you get those in. What? Oh, you've already done? You already what?
I've already messaged you to say I'll do a random number generator.
Oh, thank you.
And that I'll even index from 1 for you, so it'll go to whoever's coming first.
You're so good to me. You're so clever. So I don't know if anyone wants to take a little screen grab of this, or just quickly do it now, because this slide is going to disappear very shortly for Sophia to do her talk. So we'll give you another 30 seconds. Note your answers down, drop them in a DM to me, and then we will pick you at random. If you're not sure, just have a guess. It can't hurt to guess. And then we'll pick the winner at random, and you can get those free books so you can do some code study at home. Last few seconds. can see some entries coming in. That's brilliant. Okay, going to take the slide down now. If in doubt, just do a guess. Fab, and I'm going to hand you over to Sophia for some incredible hacks. Sophia.
Very, very quickly first, sorry, I will stick the questions in the chat because I will copy and paste them from the slides so you can look
You're
at
so
them
clever.
at your leisure.
You're so clever. Thank you. Oh God, my brain's gone. Thanks.
Okay. I'm hoping you can see my screen. Let me know if you can't. Should be the questions at the moment. And now we're going to talk about hacks. So, for those of you that might not know what that previously really badly photoshopped person is, it's Hacker Man, but I'm Hacker Woman. So what we're going to be talking about today is a security vulnerability called stack smashing, which is quite relevant to coding, programming, that kind of thing, and hopefully it'll make sense to you in a little bit. So we'll start from the very beginning and talk about stacks. So what is a stack? Essentially, a stack is a data structure which contains program instructions called subroutines for a program, and these are needed for a program to successfully run on a computer. It helps keep track of what goes next by using something called return control. So after one set of instructions is run or subroutine, it will then tell the program what to run next. So essentially, it helps things moving, keeps the wheels moving. Otherwise, if we didn't have this, it would not really work. So we'll talk a little bit about the how a stack sort of runs in a computer and how it relates to computer memory. So there are loads and loads and loads of different types of computer memory. These are sort of the common ones. So you've got kernel memory, which is quite high level, so environment variables, command line arguments, that kind of thing. We've got the stack, which is what we're going to be talking about today, which is short-term memory for local variables and functions. And we've got the heap, which is dynamic memory for loads of different objects. And we've got data for variable storage. And then we've got text, which is the very, very, very low level part of memory of the computer, which has the actual code and machine instructions for what the computer needs to do. So this is what we're going to be focusing on today, which is the stack. So these are the different, I guess, assets of a stack. So at the very top, you've got the function and the parameters of the particular code that is being run. Then you've got the return address, which is what I was talking about, sort of telling the program where to go after it executes an instruction. When you debug a program quite low level, so it will abbreviate to RSP. So if you use something called GDB, which is a tool that a lot of people use to break down code at the machine level, it will say RSP to represent the return address. You've also got a base pointer, which is abbreviated to EBP, and this points to the start of the current stack frame. So as a program is moving between subroutines and instructions, the stack will slightly change. So the base pointer helps the program keep track of where the top of the stack is for it to be able to continue running. And then you've got the buffer. So the buffer is basically allocated temporary storage for the data as it moves around the computer, trying to figure out what to do as the program is running. And then at the very, very, very top, you've got the stack pointer, which always points to the top of the stack. A lot of things happening, but don't worry, this is a very complicated, very low-level subject, so I'm going to try my best to explain it. But if you've got any questions, feel free to interrupt me or pop it in the chat, and I'll try to answer it to the best I can. So essentially, a stack has two very, very basic functions. You've got push and pop. So what push does, it pushes things to the top of the stack. And what pop does, it removes things from the top of the stack. So it always works from the top of the stack. And because of this, it's called, a stack is called a last in, first out data structure. So let's say we've got a stack with the variables 3, 2, and 1. And as you can see at the top is ESP, which points to the top of the stack for us. If we give it the function push 4, it will put 4 on the top of our stack. And then as you can see, the ESP bit has moved to the top of the stack, so the program knows what's the top and what's the bottom, what's going on really. If we use the pop function, we don't necessarily have to specify what to pop because it will always take whatever's at the top of the stack. So it goes back to just 3, 2, 1, and the ESP pointer goes back down to 3. I can imagine you're probably feeling a little bit like this, and absolutely do not worry if you do. It is quite a complex subject. Even I get confused about it sometimes, but hopefully as we go through the example in the next few slides, you'll sort of understand what this security vulnerability is. So what is stack smashing? So stack smashing is basically lingo for a vulnerability called stack-based overflow, buffer overflow. So this basically involves flooding the memory address, so that buffer section I was talking about in the stack, with more than it's allocated. And the program completely freaks out because it's like, oh my God, I don't know what to do. I only allocated 10 bytes, you're giving me 15 bytes, I don't know what to do next. And then it will usually crash or give a segmentation fault. What a segmentation fault is, a sort of TLDR, is basically a warning to say you're trying to go outside your boundaries, get back into your boundaries. So it will just stop you right there and then. But once you perform this buffer overflow, you can start to execute your own code and modify the memory to control the program flow. So once you escape that buffer, you can start to maliciously input your own instructions and code for the program to execute. So let's see, we've got this wonderful program written in C, which I won't lie is not my favorite programming language, but we're going to use C because basically C is a compiled stack-based program. So what this means is when it's compiled, it stores data and return addresses on the same stack. So this particular language is actually quite vulnerable to something a buffer overflow, and it actually allows the program to write past the end of an array that is stored in the stack. So that's why we're using C. So we've got this wonderful program, which essentially, hopefully you can see my mouse, it's printing, can you please provide a password? And then it's using a function called gets to guess what you're putting into the command line, and then pushing it to the buffer space, which we can see has been allocated 20 bytes. And then what this if strcmp means is if the comparison between the buff values, so the value that you've put into the command line, does not match, it's quite backward C. So if it does not match super secure password, it will print wrong password. Otherwise, it will print correct password, and it will assign the value of 1 to pass, and then say congratulations. So at the start, you can see that we've got a buffer that's been allocated 20 bytes. You've got the integer pass, which has been allocated 0. So what this program essentially does, if you provide it the correct password, it will then give the pass value an integer of 1. And then because in C, anything that's not a 0 is a true value in if, it will print congrats. So when you put test, it'll be like wrong password and you don't get congratulations message. If you put the very secure password of super secure password, it will say correct password and give you a lovely congratulations message. So when we go back to our little stack diagram here, what we're most interested in is this line here, because it's allocating the buffer space a space of 20 bytes. So this bit here. But let's say we want to do a buffer overflow attack. So we want to put more than the program has allocated. So we just put in a bunch of A's, which is clearly more than the allocated 20 bytes. But as you can see, it tells us it's the wrong password, but it still presents us with that congratulations message. So what's happening here is because we're providing it more than 20 bytes of the allocated buffer space, it's actually overwriting this pass value of 0, which turns this value into a non-zero, which means essentially it's reading it as a 1, and that's why we're getting the congrats message. So you're overwriting this part of the stack, and from this you can put in your own, I don't know, codes, instructions, all sorts. There's lots of different attacks you can do from this vulnerability. But I thought I'd just keep it as simple as possible this evening. But if you do want to find out more about that, just hit us a message or drop us an email, and I can provide you a bunch of resources. So this particular vulnerability has been around for quite a while. So there are a few mitigations that people do recommend. One is don't use risky functions. So in particular, this gets function that is used in this particular piece of code, it actually does not do array checking. So if you provide it with more than 20 bytes, it won't go, hang on a second, that's not what's allowed here. It will just run it, hence why it's vulnerable. There's something called ASLR, and this basically randomly moves around all the address spaces, so you don't really know where the address is going to be next. Or there's something called data execution prevention, which is shortened to DEP, and this basically marks loads of different segments of the stack as non-executable. So even if we go beyond the memory of that buffer, we cannot inject our own input, which has made Mr. Trump very angry, as you can see. And that was a very, very quick run through of stack smashing. So I have been seeing a few people pop up in the chat. Okay, cool. There wasn't questions that I just ignored, that's fine. But if you do have any questions, do let us know in the chat or message us if something comes to your mind, but hopefully I've explained that well-ish. I'll hand back to Nat.
Thank you. I'm just sneakily messaging everyone who's entered into the competition so they know that I've got their entry, so no one thinks that I've forgotten them. I'm just going to very quickly, we're about to draw the competition, but I'm just going to show you very quickly once more, just in case anyone wants to do a last minute entry. So we've had a few entries already, but there's a few people who haven't entered. So just a final chance to enter. You can just DM me the answers, have a guess. If you're not sure, have a guess. And then out of the correct answers, I've got a list here. I'll add any extras to it, and then we'll get Jenny to generate a random number and we'll pick a winner. So we'll just do a last few seconds. I wish I had the countdown music. That would be great, wouldn't it? Has anyone got any questions for Sophia whilst we're waiting? Oh, hello. That was good timing, wasn't it? Any questions for this lovely lady?
I'm so disappointed in myself for that Photoshop.
I love this. This is incredible. It's a huge improvement. Boys are boring. Sorry, any boys. We love you, really.
I think I suit a mullet really well in that photo. So.
Airline aligns very well. I think you did a good job.
Thank you.
Right, I'm going to do 10 more seconds and I'm just going to drop into the chat. Dee, I don't know if you want to pause the recording just whilst I do admin stuff.
Surely.
Oh, there we go. So just to recap, the correct answers were all the A's. Very badly written quiz, I apologize, but the correct term for a mini program within a program that you can call as a function. The command to create a Git branch is git branch and then the name of the new branch that you'd like to create. And then the magic constructor for a class in Python is __init__. So well done to Tanya for winning those bits, and we'll get those sent out to you. So just to finish off the evening in terms of what's on next. So next up in September, we have the Northeast Ladies Hacking Society are running a CTF at B-Side Newcastle. That's on the 10th and the 11th of September. So keep an eye out for that if you'd like to take part. And also if you'd like to volunteer in terms of arranging the CTF, definitely get in touch with them. They are also doing a panel at Cyberfest 2021 on the 30th of September. So keep an eye out on social media for that. And the next OWASP Ladies Hacking Society event is with London, and that's going to be on broken access control. And currently it is provisionally scheduled for the first week in October. So make sure you are part of that meetup group to get updates for that. Ways to keep in touch. If you haven't got a Slack invite, please let us know, get in touch and we can send that to you. There's also one in the channel earlier on. I think Dee Dee dropped it in there. This recording is going to go onto our Ladies Hacking Society YouTube channel, and you can also find recordings of other events on there. So it's definitely worth a look if you've missed any events, including the January career special, where there are talks from myself and Jenny about coding if you'd like to learn more about that. You can follow us on Twitter, LinkedIn, and there's also the Ladies Hacking Society podcast. If you've not already checked that out, definitely do so. We've got quite a few episodes now, and you can find that on your usual podcast provider. And then finally, make sure you're a member of all of the meetup groups. We are likely to be, well, we will be for the rest of 2021, and we may in future be sharing events online between chapters. So make sure you're a member of Cheltenham, London, North East and Glasgow. And if you're not sure about the meetup details, you can find all of those on the chapters page of LLHS.com. And then finally, so Ladies Hacking Society events are always going to be free to attend. You will never have to pay to join us. We want to make sure they are open to everyone. But if you found tonight useful and you're able to make a donation, or you've got a few pounds spare that you would like to, you can now show your appreciation, if you wish to do so, by making a donation to Refuge, who are our charity partner, and they support women and children who have been affected by domestic violence. So if you would like to donate to Refuge, you can text LHS3 to 70085, and that will automatically donate £3. As I said, you absolutely don't have to. You never have to pay to attend one of our events, but equally, if you'd like to, you can donate. And if you wanted to donate more than £3, you can just send multiple text messages. That will all go to Refuge. And then there's the only thing left is for me to say thank you so much to everyone for coming. Thank you to the LCHS team for all of their amazing presentations. I hope you've enjoyed it as much as we have. If you've got any questions, get in touch, or if you'd like a Slack link, just post in the channel. We'll be around for a few more minutes. But otherwise, thank you for coming and good night.
Thank you.
Dee Dee.